In this video, you're going to learn how to solve systems of linear equations using elimination with adding and subtracting. So if we have the equation x plus y equals -1 and 3x minus y equals 5, we would not particularly want to use substitution because we don't have a variable all by itself. Also, we could use graphing, but they're not in slope-intercept form, so that would not be my first choice. So therefore, I'm going to teach you a method called elimination, and it's called elimination because we eliminate one of the variables. If you take a look at what I have given you, we have a positive y and we have a negative y. And if we add those together, we get 0. So we are going to use what's called the elimination method, where we add the two equations together. And when we do that, we get 4x, because the coefficient in front of the x is 1 there. So if we add these, we get 4x. We have a positive y and a negative y, so those cancel out. We have the equal sign, and then we have -1 plus 5, and that equals 4. So what I have done is I have added the two equations together and eliminated the y in the process. Now I only have one variable, so I can get the x by itself by dividing both sides by 4. And 4 divided by 4 is 1, so I'm left with 1x, which is what I wanted. And on the other side, 4 divided by 4 is 1. So we get x equals 1. That tells me my x variable, so I take that value and I plug it into either the top or bottom equation, it doesn't matter which. So the top equation was x plus y equals -1. So I am going to plug in 1 for the x there. And then I have plus y equals -1. So I can solve for y now. I subtract 1 from each side. Make sure you know your rules. 1 minus 1 is 0. Then we're left with y equals, and -1 plus -1 is -2, which means my solution, remember a solution to a system is the point xy, so my solution is 1 for my x value and -2 for my y value. So that means those two lines will cross at the point 1, -2 on the coordinate grid. Now I know that that value works in the first equation, so let's just make sure it works in the second one. So to check this, I'm going to look at the second equation, 3x minus y equals 5, and I'm going to make sure that those values work. So I have 3 times 1 minus -2. So I'm going to put the -2 in parentheses there. 3 times 1 is 3. Minus a negative becomes plus a positive. So plus 2 equals 5. And 3 plus 2 certainly does equal 5. So that means it works. So the solution is 1, -2. Let's call that one example 1. So that was example 1. Let's move on to a second example. Example 2, we have the system 2x plus 5y equals 17, and 6x minus 5y equals -9. Now I can use the elimination method by adding, because I have a positive 5y here and I have a negative 5y here. So when I add those, I get 0. So I'm going to add the two equations. When I add 2x and 6x, I get 8x. The positive 5y and negative 5y equals 0, so those cancel. And then 17 minus 9 is 8. Divide both sides by 8. And it is just coincidence that both of these had x equaling 1 as the solution for x. It doesn't always happen that way. Now let's go ahead and plug these in to one of my two original problems. It doesn't matter which one. So if I copy down the original 2x plus 5y equals 17, I'm going to plug 1 in for my x value right there. So I have 2 times 1 plus 5y equals 17. So that gives me 2 plus 5y equals 17. I'm going to solve by subtracting 2 from each side. I get 5y equals 15, and then divide both sides by 5. So my solution for that one is y equals 3, which means my solution to the system is the point xy, remember that, and the x value is 1, and the y value is 3. So my solution is 1, 3. Now let's make sure that 1, 3 works in the second equation. So my second equation is right here. 6x minus 5y equals negative 9. So I'm going to plug 1 in for the x and 3 in for the y. So my equation is 6 times 1 minus 5 times 3, and that should equal negative 9. Let's make sure it does. 6 minus 15, and that does equal negative 9. Negative 9 equals negative 9, so yes, that's right, which means my solution again is the point 1, negative 3. I've noticed on some of your Google forms that some of you are not putting the solution inside parentheses, so make sure you realize that a solution is a point, and we always put points in parentheses, x comma y. Let's move on to a third example that's a little bit different. In example 3, we have the system 5x plus 2y equals 7. And we have 3x plus 2y equals 1. Now the problem is that we have a positive 2y here, and we have a positive 2y here. So if we add those, they don't go away. So what we're going to do is we're going to subtract them. But if I subtract, I have to subtract the entire line. So since I'm going to subtract, I'm going to copy down the top one. 5x plus 2y equals 7. And then I'm going to subtract everything along the bottom line. So I'm going to subtract 3x. I'm going to subtract 2y. And then I'm going to subtract 1. So it looks like that. Now we are going to do what we did on the first two examples. So 5x minus 3x gives us 2x. Now we have a positive 2y and a negative 2y, which will cancel out, equals 6. 7 minus 1 is 6. So divide both sides by 2. and that allows us to find the value of x, which is 3. Once I have my x value, I'm going to plug that value into my original equation. So my original equation was 5x plus 2y equals 7, and I'm going to plug x equals 3 in right there. So I have 5 times 3 plus 2y equals 7. Solve that, so we get 15 plus 2y equals 7. Subtract 15 from each side. Those cancel. We're left with 2y equals negative 8. And then divide both sides by 2. So my solution for y is negative 4, which means the solution to the system is the point xy, and in this case that would be 3, negative 4. So what's left to do is to check to make sure that it works in the second equation. The second equation was 3x plus 2y equals 1. So I'm going to plug 3 in for the x, and I'm going to plug negative 4 in for the y. So that leaves me with 3 times 3 plus 2 times negative 4 equals 1. And I want to make sure that that's right. So 3 times 3 is 9, plus 2 times negative 4 is negative 8, and 9 plus negative 8 is 1. So 1 equals 1 is correct, which tells me that my solution, which again was back here, 3, negative 4, that's the correct solution to the system. Let's do one more example of subtraction. Example 4 is 3x plus 2y. Oh, sorry about that. 3x plus 2y equals 10, and x plus 2y equals negative 8. So I notice that I have a positive 2y on top and a positive 2y on bottom, and that won't eliminate when I add them, so I need to subtract. So I'm going to copy the top one down. 3x plus 2y equals 10. Then I'm going to subtract the entire bottom line. So when I subtract the bottom line, I'm going to end up with negative x. If I'm subtracting x, it's a negative x. I'm going to subtract a 2y. And then I'm going to subtract a negative 8, subtract a negative 8, and when I do that, I should realize that it becomes adding 8. So let's go ahead and solve this one. I notice that I have a positive 2y and a negative 2y, so the y's will cancel each other out. So now I have 3x minus 1x, remember that's a 1 in front, that gives me 2x, equals, and then 10 minus a negative 8 becomes 10 plus 8, which is 18. Divide both sides by 2, and we get x equals 9. Once we have x, we plug it into one of the original equations. I'm going to use the top one. So I have 3x plus 2y equals 10, and I plug that x equals 9 in for the x. So I have 3 times 9 plus 2y equals 10, and let's solve that. We get 27 plus 2y equals 10. Subtract 27 from each side, The 27s cancel. 2y equals, and when we subtract we get negative 17, and divide both sides by 2, we should get y equals negative 8.5. So now it's time to check to make sure that that solution, I just found the solution to be 9, negative 8.5. So let's make sure that that works in the second equation. So my second equation, we're going to check to make sure it works. And we have the original x plus 2y equals negative 8. That was my original equation right over here. I plug in x equals 9 and y equals negative 8.5. So that will result in 9 plus 2 times negative 8.5 equals 8. Let's make sure that works. We get 9 plus, and then 2 times negative 8.5 is negative 17. And we want to make sure that that equals a negative 8. I just realized I left off this negative here. So that's a negative, and that's a negative. So that's a negative 8. 9 plus negative 17 is negative 8. So it does work. So here is our solution. Our solution is 9, negative 8.5. And that would be tough to see on a graph unless we had exact technology to help us find the exact point. So that's why we have some different methods that sometimes will work better. That should be enough to go with, and we will practice some of these problems in class. Have a good day. I would like for you to go to the Google form and complete the questions that you see there. On the Google form, I will ask you what the solution to the system 5x plus y equals 4 and 4x minus y equals 5. I will ask you what the solution to the system of that equation is. So what is the solution to that system? And that will be on your, you're going to put the answer on your Google form. Your Google form can be found right here. The link is bit.ly/elimination with addition. So please go to that URL and answer the questions. Make sure that you complete this example on this page so that you can answer all of the questions. And then there will be one more that you should write down in your notebooks. Have a good night.